just how many worlds are there in this emergent multiverse? Is it finite? Is it the Aleph not? Is it the continuum? Can you put a cardinality on
Yeah,
it?
okay, good. So it's ill-defined, but at least as big as about 10 to the power of 10 to the power of 20. So the reason it's ill-defined is because there's a bit of convention as to exactly how you carve the world up into worlds, so the universe up into worlds. So my criterion for when I've got two worlds is when they've decohered, when they're evolving effectively independently. But you might imagine deciding to grain them a bit finer and say, well, I won't just consider whether the particle is left or right, I'll consider exactly how far left it is. And now I might say, instead of having two worlds, a billiard ball left and a billiard ball right world, now I've got four worlds, a billiard ball a little way left, a billiard ball a long way left, a billiard ball a little way right, a billiard ball a long way right. And that's still going to work fine because I'm still going to have decoherence, but now I've got four worlds rather than two. And I could keep fine graining like that. And eventually I'll fine grain so much that decoherence stops being present and my assumption that I could treat these worlds as autonomous and separate starts to break down. But there's going to be no very precise moment at which you can say that's exactly the amount of decoherence that needs to be present for there to be worlds, because this is an emergent higher level notion. And exactly how you decide to put that threshold very sensitively affects the number of worlds. So the number of worlds is relative to how we disambiguate worlds, but under any sensible disambiguation of worlds, it's going to be super astronomically large, statistical mechanically large, 10 to the power of 10 to the power of something. It's probably true at least within the observable universe, it's probably any sensible way of disambiguating worlds is going to be finite. So that under any scheme you could come up with here, you'll get a finite number. So the cardinality is probably finite, but ill-determined. And I think one of the interesting philosophical questions Everett throws up is how to think about this kind of indeterminateness. And there are a lot of ways in which this you can see relations to some of the extant metaphysical literature on vagueness or indeterminacy. I think one of just speaking of the broader philosophical point for a minute, there's been a lot of philosophical discussion of the Everett interpretation, but until pretty recently, it's mostly been about trying to kill it or prove it or protect it from being killed. It's all about, is it a viable interpretation of quantum mechanics? I actually think there's a very rich range of interesting MLE, metaphysics, language epistemology type questions that one conveys by saying, okay, let's suppose for the sake of argument that many worlds theory is right, and then ask what implications that has for how we think about a bunch of extant questions in other areas of philosophy.
What are some of the parameters that go into one of the equations that somebody might use to try to calculate this number 10 to the 10 to the 20? Because I'm guessing one thing that comes to mind is the age of the universe is probably very important, because that's totally going to constrain the amount of worlds that could have evolved.
Yeah. I mean, if you want to see where I'm getting that kind of number from, suppose I have some process that leads to world branching. So the kind of process that lead to world branching are things whereby microscopic indeterminacy gets magnified up to macroscopic indeterminacy. So explicit quantum experiments are the obvious one that we've talked about. But classically chaotic things tend to have this character as well. So classical chaos happens when a system is very, very sensitive to its initial condition. The weather is the classic example. If the butterfly flaps its wings, I'll get a hurricane a year from now. If my system is sensitive to initial conditions like that, and if my initial conditions are actually in a quantum superposition of goings on, even if it's a very small quantum superposition, even if my particle is in a superposition of being here and being 10 to the minus 8 meters that away, well, if the system's classically chaotic, that very small difference will get magnified up to a macroscopic difference. So in reality, in the quantum weather system, it's not that the very small differences in the current state of the world will affect whether there's a hurricane next year. It's that it's definitely true there'll be a hurricane next year and not a hurricane next year in different branches. And that's happening as a consequence of the fact that dynamics is so sensitive. So then you want to look in the universe, where are there processes of this kind? And an example would just be the way in which the individual planets around stars form. So, we've got 10 to the power 20, order 10 to the power 20 stars in the observable universe. There's going to be at least one random process associated to each of those, at least one chaotic process associated with the formation of each of those solar systems, the number of planets they're going to have, where those planets are going to be, those are all chaotic processes. So if I've got some binary process that can happen a different way in each of those 10 to the power 20 planets, then I've got 2 to the power of 10 to the power of 20. Now, you could inflate that number very easily. That was an extremely cautious approximation. Generally speaking, I tend to think once you've established the numbers of the order of something to the power of 10 to the power of something, you've sort of established it's as big as things get, short of infinity. And trying to pin it down further than that is can become a bit of a mug's game. But that's the kind of thing.
Graham's number is a whole lot bigger than 10 to the 10 to the 20.
Sorry, say again?
I said Graham's number is a whole lot bigger than 10 to the 10 to the 20.
Yeah, no, of course. Well, I mean, and 10 to the power of Graham's number is bigger than that, I guess. I mean, that's absolutely right. But from a physicist's point of view, there are small numbers. There are astronomical numbers there's small numbers like 10. There are astronomical numbers like 10 to the 20, and there are stat mech type numbers like 10 to the power 10 to the power 20. And my hunch would be that you'd probably find that quantum branching ends up being a stat mech number rather than some vastly constructible, finite but ridiculously larger number than that. But I don't have a huge amount of confidence in that, second order confidence in that judgment.
Okay. And then the other potentially naive question that I have about these many worlds is how decoherence, or maybe decoherence isn't even the right concept to employ here, but how it relates to special relativity and simultaneity. So does decoherence propagate instantaneously or faster than the speed of light? If something branches, if there's some event, a decohering event, a billion light years away, are we branching here at that exact same time?
Yeah, good. So there's not a naive question at all. It's interestingly contentious in some of the literature. And it's worth saying at the fundamental level, quantum physics is local, which is to say a change in the quantum goings on at a given point can only influence the quantum goings on in the forward light cone at that point. That's just a consequence of the dynamics of quantum mechanics. So what we're talking about is how do you want to think about this at the emergent level of the branches of the worlds? The way I prefer to think about it is the branching as a local phenomenon. So decoherence is spreading out at the speed of whatever interaction is causing decoherence. If decoherence is a physical process whereby the location or whatever other property of an object is being recorded in the states of other objects, then that recording process is a dynamical process. All of our dynamical processes are local processes. They all propagate at sublight speeds. So the branching spreads outwards at the speed of whatever the fastest interaction is that's doing decoherence. As a practical matter, for any large system, that's going to be light speed. So you can think about the branching occurring on the forward light cone of the event that causes the branching. And then there are some subtle issues of non-locality that arise when I ask how that expanding branching process comes to interact with another expanding branching process produced by another quantum splitting event that happened on somewhere space-like separated from me. Now, you can, if you want, or instead of that, you could decide I want to use a global language of branching, and in that sense, you'd want to say that the event of a measurement being made a billion light years away causes you to split instantaneously, but that would be conventional. I mean, that would be kind of analogous to the decision to use a certain foliation in describing special relativity. I can describe special relativistic goings on globally on a given hypersurface and then evolve a hypersurface to a hypersurface, and that can be a useful way of talking. But the choice of hypersurface is a conventional matter, and it doesn't say anything deep about what's happening physically. And so I think that's kind of how I think about the branching of worlds. I think there are lots of situations in which a global notion of world is convenient, but our choice of doing it would be a convention. and the splitting would likewise be a convention. I mean, it's a bit like, you probably know this example. I mean, if I travel away, if I travel off into space 10 billion light years, and my wife gets bored waiting for me after 9 billion light years and divorces me, am I divorced immediately? Or do I wait for the signal to catch up? Well, there's a perfectly reasonable set of definitions that says whether I'm divorced or not is a global property, and I'm instantaneously divorced if I've been divorced, in which case divorces are defined on Earth variation, but of course it will be conventional whether we defined it. So that change that occurs to me when I am divorced is not really it's a sort of conventional change. It's not nothing physical happened there. There's no violation of superlumin of the speed of light barrier in the fact that my divorce happens instantly.